Hello, welcome to section 2.1, and chapter 2 in general is about graphs and how to represent data. So we got just a couple more lessons before we get into some computations. Alright, so you need to think of three things when constructing an appropriate graph. You need to think of the number of the variables. Remember, variables are like things that change with respect to something else. You think of the data type. There's different types of data. We're going to discuss all of these things, like different types of variables, different types of data, and then the purpose of the graphical display. And if you look down the bottom of the page here, we kind of break everything down into the type of the variable. You can see univariate, bivariate sort of data. Data type, there's categorical versus numerical, or quantitative is another way of saying numerical. And then the purpose. Alright, so that's basically your three things you need to ask yourself, and then you'll have an appropriate way to display your data. Alright, so with that said, let's talk about what is a variable. It's anything that changes or could change, any characteristic whose value may change from one individual to another. For example, political affiliation, number of textbooks purchased, distance from home to college. These are things that are different from one person to another person. Number of textbooks purchased, different from one school to the next school. Political affiliation and so forth. Data. What is a piece of data? It's the value for a variable. So it might be one person is Republican, one person is Democratic. Changes, that's the value for a variable individual. Results from making observations either on a single variable or simultaneously on two or more variables. Statistics is all about looking at the data. Data can be univariate, bivariate, or multivariate. Univariate. Uni means probably one, and bi means two, and obviously multi means more than two. So univariate consists of observations on a single variable. We might be looking at the GPA. You might want to know the average GPA of a class. Suppose that a PE coach records the height of each student in his class. Okay, so how would we display that in a graph? Alright. You got quite a few options for univariate data. Height would be considered quantitative or numerical, and it's continuous. So you'd probably pick one of these. Bivariate data that consists of pairs of numbers from two variables. That's where you get a scatter plot, where you plot one variable against another variable. Suppose the PE wants to record height and weight. Maybe there's an association with height and weight of each student in his class. And then multivariate, it's when you get more than two, height, weight, number of sit-ups, and number of push-ups. Okay. Multivariate, you don't really display that. You got to do like multiple displays of scatter plots. Two types of variables. One is categorical or qualitative. It's a quality, like a the something like that. Categorical consists of it says qualitative. It's the same. I guess I didn't mean to put a blank there. That's okay. Consists of categorical responses. Which of the following are categorical? Car model, categorical. Birth year, you fit in a category. type of cell phone. You're fit in the category of iPhone or Android. Zip code. Even though it's numbers, it's a category you fit into. Which club you have joined. It's a category. If you join the math club, you fit in that category. Whereas quantitative, this is supposed to be quantitative. And by the way, the AP does not use numerical. They just use quantitative. You won't see numerical, you just see quantitative data. Observations or measurements take on numerical values. And you can perform math on these. For example, you can find the average of these things. You can find the average GPA. You can find average height. Can you find average code to combination locks? Really wouldn't make sense. There would be no value in finding the average code to a combination lock. So I'd say that's probably not. Number of text messages a day, we can find the average number of that. Textbook weight, we can find the average of. So things like that are quantitative. And there are two types of quantitative variables. We have discrete, dist. Discrete and continuous. So discrete, isolated points along a number line, usually counts of items. You can count them. Whereas continuous are usually a measure of something. It might be using a ruler, it might be using a scale, but it's typically measuring something. And it can take on any number on a number line. Whereas discrete, you could have one item, you could have two items, you could have three items, you could have four items. Continuous, you could be 2.5 feet tall, I guess, for a baby. So examples of continuous would be like GPA. You could be anywhere between a 3 and a 4. Anywhere in between. Heights. You could be anywhere between 0 feet high and 10 feet tall. High. Weights and times are another one. You gotta be careful with money. Like with dollars. Can you take on any dollar amount between 0 and $1? No. You can be 50 cents, but you can't be 50.5 cents. So it kind of has context allowed in this. So discrete versus continuous is not always easy, but most of the time it is. Think count versus measure. Alright, if you have one, identify the type of the following variable. It's going to be either categorical, quantitative discrete, or quantitative continuous. Those are the three options for this. The color of cars in the teacher's lot. By the way, pause the video, work through these for yourself and see how you do. And we're back. Color of cars in the teacher's lot, that's definitely categorical. You fit into black category, white category, red category, or non-black and white category. So however you want to make your categories. That is definitely categorical. The number of calculators owned by students at your college. Can you find the average number of calculators owned, at a college? Sure. So it's definitely quantitative. It's definitely quantitative. Is it discrete or continuous? Can you count the number of calculators owned? Yeah. Do you own 1, 2, 3, or 4? Yeah. Can you own 2.5 calculators? No. So we're looking at discrete, quantitative discrete. The zip code of an individual. That's categorical. Even though it's numbers involved, it's a category. The amount of time it takes students to drive to school. That is definitely numerical because you can find the average of it. And it could take on anywhere from 5 minutes to 10 minutes and anywhere in between. So this would be continuous. Number 5, the appraised value of homes in your city. This one's tricky. It's definitely numerical because you can have an average appraised value. But I mean, technically, we're counting dollars and cents. We're counting them. And you can't have fractions of cents, so it's discrete. This one is discrete. Discrete quantitative. Here's the chart. This is also in your book, and again, this is helps us answer the three questions: what type of variable? Sorry, the number of variables, the type, and the purpose of the display. All right, so we don't necessarily need to memorize this, but it's a good little chart to have as we work through. And so today we're going to go through these two, kind of some intricacies of these two, and then the next class we're going to make our way through the rest. Okay. Displaying categorical data. Take a minute, pause the video, read example 2. I'm not going to read that to you right now, so pause. Okay, we got different types of helmets. We got the number of times each helmet is represented. This is a frequency. Oop, there we go. This is called a frequency distribution. All right. Frequency distribution, a table that displays the possible categories along with the associated frequencies. Or relative frequencies. Here's relative frequency. Relative frequency is like the proportion. Frequency for a particular category, that is the number of times that a category appears, while the relative frequency is the proportion of observations that belong. So number of times represented, proportion of the time represented. Relative frequency is easily found. You just take the frequency and divide it by the total number of observations. So to get this 0.480, you take the number for C divided by the total. 816 divided by 1700 would be your relative frequency. And if you do it correctly, you should have 100%. 100% of the time, you're one of these options. You should add up to 100%. Okay, next is the bar chart. We all know what a bar chart is. It's got a horizontal line with the categories: no helmet, non-compliant helmet, or compliant helmet, associated with the data here. We've got the vertical line. The vertical line should start at 0. There are exceptions to this, but in categorical data, we would like this to start at 0 to see the bars. And then you have options for the vertical line. You could put the frequency, like done here, or you could put the relative frequency as well. And that would also have, it would look exactly the same. You would just have relative frequency. All bars should have the same width, so that both the height and the area of the bar are proportional. You want proportional. You want these to be proportional to each other. Moving on to comparative bar charts. It's like when you put two bar charts next to each other. Comparative bar charts. Construction use the same horizontal and vertical axes for the bar charts of 2 or more groups. Usually color coded. And for bar charts, you should use the relative frequencies. For comparative bar charts, use the relative frequencies on the vertical axis, because you can get things that look a little weird. Use relative frequency rather than frequency on vertical axis so that you can make meaningful comparisons even if the sample sizes are not the same. And so here's an example. Let's go ahead and pause the video and read through this example. All right, example 3. So we can see here, this would be the bar chart if you just used frequency. And here you can see that less than 250 miles here. I mean, it looks like the parents are not really caring all that much. Okay? You've got quite a few parents in this, you got quite a few less in here than in here. So this bar chart's a little misleading. If you look at the relative frequency of the parents, the majority of parents fall in this category. I mean, it's hard to see that here. This is a lot higher than this, but if you look at the relative frequency, the parents are a lot higher than the students here. So something to think about. In general, you want to use relative frequency for comparing. And what that does, you can make meaningful comparisons even if sample size is not the same. Alright, last page. Let's see if we can fit it in this video. So pause for a moment, read through example 4. See if you can figure out, explain why the graph may be misleading. And I'm assuming you paused and we're back. So why is this graph misleading? Did you notice something? It really looks like PS3 is way more represented than Xbox 360, but really, if you look here, that's 46% versus 49%. Does this graph show the difference between 46 and 49%? I mean, this almost looks like it's doubled, doesn't it? And it's because we didn't start at 0 here. That's why it's important to start at 0 for bar charts. You might get misleading graphs. People might be out there to mislead you, believe it or not. Alright, pause the video. Read through example 5. So pause the video now, read through example 5, try A, B, and C. And away we go. What proportion of subjects in the study were randomly assigned to take St. John's wort? Explain why this value makes sense. So here's, looks like some sort of study here. So we have St. John's wort, and we can add those up. So if we add those up, that's 113. And the total, if we add up all of these, is 338. I'm just going to put that right there. Okay. So what proportion of subjects in the study were randomly assigned to take St. John's wort? 113 out of 338. Which is that proportion, so 33%. Why does that make sense? Well, when they're designing their study, it's nice to have an equal amount in each treatment. If you can manage. You don't have to, as long as you have enough replication. But in general, it is nice to have equal groups. Next, find the distribution of change in depression. For the subjects in the study using relative frequencies. So for the full response, if you add these up, you get 91 for that. For partial response, if you add these up, you get 55 for that. And for no response, if you add these up, you get 192 for that. Alright, so for the full response, that would be a proportion of 91 out of 338. That's some computation. Nice. For the partial response, you're going to end up with 55 out of 338. And for no response, you're going to end up with 192 out of 338. Now if you add those up, it should add up to exactly 1. And then lastly, see what percent of subjects took Zoloft and showed a full response. So full response took Zoloft. That's the 27 out of 338, which is 0.08, which is about 8%. And that is all the time I have. This is your homework. Bye-bye.